All right, let's get right into it. What if I told you Google just dropped what might be the smartest AI model in the world, and it landed with barely a whisper? Well, that's what we're going to unpack today, the story of a massive AI upgrade that showed up without the usual fireworks. So just think about this for a second. What if the biggest leap forward in artificial intelligence this year already happened, but it was so quiet, so under the radar, that most of us just missed it? This isn't just some hypothetical question, because this is exactly the story of Google's Gemini DeepThink. And look, this isn't about a new chatbot that's a little bit better at writing poems. No, this is about a fundamental change in an AI's ability to actually reason, and it's already making waves out in the real world. See, Google isn't even really pitching DeepThink as a cool for you and me. They've built it as a specialized reasoning engine. It's designed to help scientists and researchers get their hands dirty with the really tough problems. You know, the ones that don't have a simple answer in a textbook, or all the data is messy and incomplete. This is all about pushing the absolute frontier of what intelligence can do. Okay, but talk is cheap, right? So let's get to the good stuff, the hard evidence. We're going to look at the actual numbers, the benchmarks, that show just how much of a beast this new model really is. First up is a benchmark called Humanity's Last Exam. And yeah, with a name like that, you can bet it's tough. It tests expert-level thinking in fields like advanced math and physics. And here's the key, it can't use any tools. The model has to figure it out with pure reasoning. And what's wild is that DeepThink is already showing a solid 8% lead over Claude for Opus, which was, until like 5 minutes ago, the top competitor out there. But hold on, because this next one, this is where things get absolutely insane. Codeforces is basically the Olympics for competitive programmers. It is the most prestigious platform on the planet. And just look at that gap on the screen. That's not a small step up. That's a chasm. That huge difference you're seeing isn't just a slight improvement, it's a jump from being a really good human coder to, well, something else entirely. And it all comes down to this number, 3,455. That's DeepThink's score. Now, to put that into perspective for you, that is a rating that only a tiny, tiny handful of the best human programmers in the history of the world have ever achieved. We are talking about a world-class, genius-level ability to reason through complex algorithms. And this quote from a developer who saw the news just says it all. The old AI record was 2727. DeepThink didn't just beat it, it pole vaulted over it to a level that's on par with the 8th best human competitor on Earth. This is way beyond just writing better code. This is superhuman problem solving. Okay, last benchmark, I promise. This one's called Arc AGI2, and it's designed to be cheat-proof. It tests pure abstract reasoning, the ability to learn new concepts from just a few examples, not just spitting out memorized facts. A few months back, the score was around 30%. Today, DeepThink is at nearly 85%, blowing past the human average of 60. That kind of jump on a test designed to measure true intelligence in just a matter of months, it's just staggering. So the numbers are obviously impressive. But who cares, right? Why does this actually matter? Well, let's pivot away from these abstract scores and look at the real human impact this tech is having right now. Let's see how scientists are using this new reasoning power to speed up actual discovery. First, let's meet Lisa Carbone. She's a mathematician at Rutgers, and she's working on some seriously mind-bending problems, trying to build a bridge between Einstein's theory of relativity and quantum mechanics. You know, just solving the deepest questions in physics. No big deal. So she decides to feed one of her research papers into Gemini, kind of just to see what would happen. This is a paper that took years of work and had already been checked by other human experts. And the AI's response was just stunning. It found a fundamental math error in one of her core propositions and laid out 3 separate, undeniable reasons why it was wrong. And as she says, the model's reasoning was completely, totally correct. It found something she, her colleagues, and other experts had all missed. So, to put it simply, the AI acted like a super-powered peer reviewer. It took a paper from the absolute frontier of physics, spotted a critical mistake that multiple human experts missed, and then explained precisely why it was wrong. This is a whole new level of scientific partnership. Okay, next up, we've got the Wang Lab. These folks are working on growing brand new 2D semiconductor materials. Think of them as atom-thin sheets that could be the key to building the next generation of electronics, especially as we start hitting the physical limits of silicon. Now, growing these things is incredibly tricky. It can take human experts weeks, even months of just trial and error. So the lab asked DeepThink to come up with a new recipe. And the result? They grew a crystal that was 30% bigger than their target size. It was, in their own words, the best result their lab had ever seen, period. And what's really cool is how the AI did it. It didn't just spit out a single number like set the temperature to X. No, it gave them a whole thermal profile, a complex, step-by-step recipe for success that achieved in a flash what would have taken humans months to figure out, and it led to a literal record-breaking discovery for their lab. So we've seen DeepThink as this incredibly powerful new tool, but Google didn't just stop there. They built a whole new system on top of it that signals the next major evolution, moving from an AI that helps you to an AI that is an autonomous colleague, capable of doing research all on its own. And that system is called Althia. Think of it as an AI research agent. It's powered by DeepThink, but its whole purpose is to autonomously tackle the kind of open-ended research problems that PhD students get stuck on for years. So how does it work? Well, it uses this simple but unbelievably powerful loop. First, it generates a possible answer. Then, and this is the absolute game changer, it checks its own work. It verifies everything. If it finds a little mistake, it revises and fixes it. If the whole thing is junk, it just throws it out and starts from scratch. It's like a brilliant student who can proofread and rewrite their own essay hundreds of times a second. And this table from Google just perfectly captures where we are at this exact moment. They created it to track AI's contribution to science. Notice that level 3, landmark breakthrough, is totally empty. AI hasn't cured cancer or solved fusion yet. But then look at level 2, publishable research. That row is filling up fast. And importantly, it's filling up in every column, from projects led by humans to full collaboration and yes, even to fully autonomous work. The AI is already doing the research itself. So this all brings us to the biggest question of all. What happens next? Because the most critical thing to understand in this whole story isn't just how smart this model is today, it's the absolutely staggering speed at which it's getting smarter. This timeline right here tells you everything you need to know. The first version of DeepThink, which was already a huge deal, solved about 65% of these math Olympiad problems. Just 6 months later, the next version hits 90%. That massive jump happened in half a year. And then you see the Althia Agent on top, scoring even higher while using less computer power. It's not just getting stronger, it's getting more efficient. Now, when we look at much harder PhD-level math, you can see the raw model starts to struggle a bit, scoring around 38%. It's still incredible, but it's hitting a wall. But even here, that Althia Agent, with its self-correction loop, gives it a huge boost, up to 46%. That's the difference between a tool that just helps and an agent that can actually lead the way. So let's bring it all home. We are watching in real time as an AI climbs its way up that contribution ladder. It is already, right now, autonomously producing research that's good enough for academic journals. Which leaves us with one final massive question. If it can do that today, how long until it produces a true landmark breakthrough? Given the rate of progress we've just seen, that day might be coming a lot sooner than any of us think.